I guess I will.
So when it comes to scale vector diagrams, there are two types.
Uh, yeah.
One is the head to tail,
Mhm.
which will look something like this. For example, the shape goes like this. So you have the force one and the force two, and you have the resultant force. Another example would look something like this. Force one, force two, force three. The difference between these two is that there's a resultant force here. So this is what they call an equilibrium force triangle. Okay, so that's number one. We're not going to go through that today. We're going to be using number two, parallelogram method. All right. Now, why do we use parallelogram method? Because of this. The key is resultant force. It's easier to use that. And if you see two forces here like this, it's very easy to visualize the parallelogram method. Because if you draw some dotted lines here, you could actually sketch the graph, the scale vector diagram inside. So it will look something like that. Okay, so look for patterns, something that looks familiar to how a parallelogram looks like, and that could be what you should be working on, choosing between these two methods. Okay, so we're gonna work with this. Let's erase everything and get started. The first thing you want to do is decide on a scale. The scale should be, if you got like 8 Newton here, something that's comfortable. I think 1 cm to 8 Newton is comfortable because you'll be drawing like a 8 cm line, and you should try that in your paper. Each file looks small. Why does yours look small?
1 cm to 8 Newton. So I did 1 cm to 1 Newton.
1 cm is 1 Newton. 1 cm is 1.
1 cm. Then I did wrong.
So you should be drawing an 8 cm line.
I did wrong.
Okay?
I broken.
So what you can do is draw a horizontal guideline and then use a protractor, mark 28 degrees because you're looking at a isosceles triangle. The two lengths are equal. Mark 28 degrees, measure up to 8 cm. Okay? Put the arrowhead inside. Do the same below. 28 degrees, measure up to 8 cm. Put the arrowhead inside. Draw dotted lines that are parallel. So this should be parallel to this one. And then this one parallel to this one. So I'm doing freehand for this. It's very ugly, but this is what you should be doing. So from here, right? From this intersection to this intersection, draw a line and put a double arrowhead. Yeah. Okay, once you have this, measure the length. Okay, so example, if you measure it to be arbitrary value 11 cm, then it should be 11 Newton. So the answer here would then be 11 Newton.
Nice. 43. That's
Yeah,
45.
we've not drawn yet. We've not drawn yet. So check. We'll check the answers later. But that is the basics to doing this question. Now, the next thing you want to do is you should erase this and replace it with 8 Newton. I put 8 cm to tell you that you should measure 8 cm, but that should not be part of the answer.
Oh,
Remember your arrowheads because I see a lot of times students don't draw arrowheads. Do you use a pen to draw?
yes.
Oh my god, okay.
Wait, will they be married?
It won't if your drawing is drawn very nice and accurate.
Sama pencils. There's a pencil. Yeah.
They have pencils.
Okay. My drawing is very trust. About a correction tape. Huh?
Okay.
There's no correction tape.
And there's one more step
What's the
to
drive?
do.
No drive.
What is the one more step?
Calculations.
You need to measure this,
Yeah.
which
What?
is 28 by right, because they are both equal in magnitude. So you should be getting 28.
Wait, 28
But
what? Sure.
this should be 28.
Yeah.
So you need, because you need to fill in this. So this should be 28 degrees. This should be 1 Newton. Then the resultant force, measure it with your ruler and convert it back to the scale.
Call it back to the scale, bro. So the
And
CM.
that's it, you're done. You're done for this question.
CM not Newton, bro. So resultant force is Newton or Newtons.
Newton.
Newton, where it says Newton? What here? This guy said 14.2 cm.